In this video, we shall look at how to perform differentiation of inverse hyperbolic functions. Examples of inverse hyperbolic functions are as follows. Inverse hyperbolic sine of x, inverse hyperbolic cosine of x, inverse hyperbolic tangent of x, and so on. Let's look at the following function. What is the differentiation of y with respect to x? So first let's express x in terms of y. That will be x equals to hyperbolic cosine of y, which means dx dy is hyperbolic sine of y, which also means dy dx is 1 over hyperbolic sine of y. Now from the following identity that says the square of hyperbolic cosine, say theta, minus the square of hyperbolic sine of theta equals to 1, we can express the dy dx as 1 over square root hyperbolic cosine squared y minus 1. And using this definition for hyperbolic cosine of y, this will simply become 1 over square root x squared minus 1. And that is dy dx. How to differentiate inverse of hyperbolic tangent of x with respect to x? We do the same trick. We express first x in terms of y. That will be hyperbolic tangent of y, and we perform dx dy, and that is the square of hyperbolic secant of y, which means dy dx is 1 over the square of hyperbolic secant of y. Since we know that hyperbolic cosine squared minus hyperbolic sine squared equals to 1, dividing this equation by hyperbolic cosine squared, you get 1 minus hyperbolic tangent squared equals hyperbolic secant squared. So using this identity, dy dx above will become 1 over 1 minus the square of hyperbolic tangent of y. Since hyperbolic tangent of y is x, we see that dy dx is simply 1 over 1 minus x squared. And that is the final answer. Let's look at the following function. Here in the argument of the inverse hyperbolic sine, you have a factor half in front of x. It doesn't matter, the same thing follows. So x over 2 is hyperbolic sine of y. So that means x equals to 2 hyperbolic sine of y, like that. So that means dx dy is 2 hyperbolic cosine of y. What that means is dy dx is 1 over 2 hyperbolic cosine of y. Again, using the identity hyperbolic cosine squared minus hyperbolic sine squared equals to 1, we see that dy dx is 1 over 2 square root 1 plus the square of hyperbolic sine of y. Since we can express hyperbolic sine of y in terms of x, using that expression, you get the following. So 1 plus x squared over 4, which can be simplified into 1 over square root 4 plus x squared. And that's the final answer. The following inverse hyperbolic tangent also have a constant 1 over 3 in front of the argument x. expressing x in terms of y, you will get 3 times hyperbolic tangent of y, which means dx dy is 3 square of hyperbolic secant of y. So dy dx, which is what we are interested in, is 1 over 3 square of hyperbolic secant y. This can be expressed using identity in terms of hyperbolic tangent squared as 1 minus hyperbolic tangent y squared. Using this expression, we can express the above result in terms of x, which is 1 minus x squared over 9. So making the denominator the same for the terms within the bracket, you have 1 over 3 over 9, 9 minus x squared, which will give you 3 over 9 minus x squared. And that's the final result. Let's perform the differentiation of this function with respect to x. So step number 1 is to express x in terms of y. So that's going to be x minus 1 over x is hyperbolic sine of y, or x minus 1 is x times hyperbolic sine of y. So gathering the terms with x, you get 1 minus hyperbolic sine of y equals 1, or 1 over 1 minus hyperbolic sine of y, that it being x. So first let's try to differentiate x in terms of y using this result. We shall use the quotient rule. Differentiating the top first, you get 0, and then minus. Now let's differentiate the bottom and multiply that with the top. So differentiate the bottom, or the denominator, we get minus hyperbolic cosine of y, and multiply that with the numerator over the square of the denominator, which is that. What that means is dy dx is inverse of that, which is 1 minus hyperbolic sine of y squared over hyperbolic cosine of y. We know hyperbolic sine of y in terms of x is given by this expression. What about hyperbolic cosine of y in terms of x? Using identity, we know hyperbolic cosine of y is square root 1 plus the square of hyperbolic sine of y, which is just that. So it's x minus 1 over x squared. Substituting this expression and that expression in here, we get 1 minus x minus 1 over x squared over that, which is square root 1 plus x minus 1 over x squared. Let's try to simplify this dy dx. So the numerator can be rewritten as x minus 1 over x squared, and the denominator can be written as x squared plus x minus 1 squared over x squared. You see that this x will cancel that x, and that's going to give you 1 over x squared for the numerator, and the denominator will have 1 over x from that term, followed by square root of this x squared plus x squared from there, so that's 2x squared plus 1 minus 2x once you expand the bracket and then combine the terms with the x squared in front. This is what you get. So this 1 over x will cancel one of the 1 over x from the top, and your final answer will simply become 1 over x square root 2x squared minus 2x plus 1. And that is the final answer for the dy dx, where y is given by that expression. How do we differentiate this function with respect to x? Now, in the argument, a is a constant. As always, step number 1 is to express x in terms of y. So to do that, we invert that equation, and it's going to be hyperbolic tangent of y. And then we express x in terms of y. After some algebra, you will get the following expression for x. X is hyperbolic tangent of y minus a over 1 minus a times hyperbolic tangent of y. From this equation, we can work out dx dy using the quotient rule. So differentiate the top, you get the square of hyperbolic secant of y, multiply with the denominator, which is 1 minus a hyperbolic tangent of y, minus, now you differentiate the denominator, and that's going to give you minus a hyperbolic secant squared of y times the numerator, which is hyperbolic tangent of y minus a, and divide this entire thing by the square of the denominator. Like that. You immediately see that this times this will cancel this times that. So these two terms will simply cancel out. And this numerator will simply become hyperbolic secant squared y 1 minus a squared, which we have written here. That means dy dx will become 1 minus a hyperbolic tangent of y squared over hyperbolic secant square y 1 minus a squared. From identity, we know that this term here is just 1 minus the square of hyperbolic tangent y. So this expression will simply become that expression. Now all we have to do is to substitute the expression for hyperbolic tangent of y in terms of x in here and in here and do the algebra, which will simply become 1 minus a hyperbolic tangent of y is a plus x over 1 plus ax squared, divide by 1 minus a squared, 1 minus the square of this expression, which is a plus x over 1 plus ax squared. Let's make the denominator equal in both up and down, and that's going to give you 1 plus ax minus a plus x over 1 plus ax squared, so that is this term, divided by 1 minus a squared, 1 plus ax squared minus a plus x squared over 1 plus ax squared. You see that this will cancel that. This will cancel that because it's a times x with a minus sign, which will result in this. You see that this will cancel that, which can then be expressed in this form, so this goes away and give you the final answer for the dy dx, and that solves the problem. Thank you for watching.